In this lesson, we're looking at the equation of a circle. So before we come up with the equation of a circle, we want to make sure that we know what the definition of a circle is. So in the coordinate plane, circle is the set of all points that are a fixed distance, and we call that distance r for radius, and they are all the same distance from the center, and we call that center h, k. So in this diagram, we have a circle whose center is h, k, and the point P is any point x, y on the circle that is r units away from h, k. So we have this right triangle then created by connecting those 2 points and then making a right triangle to form them. And what are the coordinates of point A? Well, it would have the same x coordinate as P, so it would be x, comma, and it would have the same y coordinate as the center, so it'll be x, k. So x, k. So we found that this point is x, k, and we'll use absolute values to write expressions for the lengths of CAP. So CA is the absolute value of, well, I look at these 2 points, and since they're on a horizontal line segment, I'm really only counting the spaces. Since it's a horizontal line segment, the K, the Y coordinate is the same, so I'm going to kind of ignore that. So it'll be the absolute value of x minus h. And then the length of PA, my x coordinates are the same, they're both x, and so I can just subtract the y coordinates, so absolute value of y minus k. And then it says to use Pythagorean's theorem. So x minus h squared plus y minus k squared is equal to r squared. Write the equation of the circle, which we saw on the previous screen, was x minus h squared plus y minus k squared equals r squared. So why did we need absolute values when we expressed the lengths of the legs, but not when we wrote the relationship in step C? In step C, we squared the difference. Which guarantees a positive value. Like absolute value, step B does. Suppose the circle has its center at the origin. What would be the equation of that circle? If the center of the circle is at the origin, then your h, k is 0, 0, which means you'd have x minus 0 squared plus y minus k, y minus 0 squared equals r squared. When you simplify this, x minus 0 is just x, and x squared is just x squared. So you'd have x squared plus y squared equals r squared. So that's what your equation would look like. So we're writing the equations of circles. In example 1, part A, you see that we're given the center, -2, 5. We're given the radius, and we substitute in the h, k, and the r values, and then we simplify. So in part B, we're doing the exact same thing. We're taking 4 and substituting it in for h, taking -1, substituting that for k, and substituting in the square root of 5 for r. When we simplify this, we have x minus 4 quantity squared, and then y plus 1 quantity squared, because minus negative 1 becomes plus positive 1. The square root of 5 squared would be the square root of 25, which you should know is 5. Suppose the circle with this equation is translated by using this rule. What would be the equation of the image of the circle? Well, the translation isn't going to change the size of the circle, so I know the right side of the equation isn't going to change. On the left side, the center of my given line, circle, is 2, negative 4. And when I take that and apply this rule to it, then the new center is 5, negative 5. So my new equation will be x minus 5 squared plus y plus 5 squared equals 7. More practice writing the equation of a circle. Here's our standard equation. So x minus 4 squared plus y minus 3 squared equals 4 squared, which is 16. Part B, I have x minus negative 1 squared plus y minus negative 1 squared equals the square root of 3 squared. Cleaning this up, I have x plus 1 squared plus y plus 1 squared equals square root of 3 squared would be square root of 9, which is just 3. Another kind of problem that you should be able to do with the equation of a circle is figure out whether a point lies on a circle. So I'm trying to find out in part A if the point 3, square root of 7 is on the circle that is centered at the origin and containing the point negative 4, 0. And so they plotted a point at the origin, they plotted a point at negative 4, 0, and then used that information to draw the circle. Well, if the center is at 0, 0, and it passes through negative 4, 0, that's why the radius is 4, because negative 4, 0 is 4 spaces away from 0, 0. And then they wrote the equation of the circle and got x squared plus y squared equals 16. They plugged in the x value of 3 and the y value of square root of 7 into the equation, worked it out, and saw that it does satisfy the equation of the circle. Same kind of problem. I'm given a point, 1, square root of 6, and it has a center, negative 1, 0, and the circle contains the point negative 1, 3. I'm trying to find out if the point 1, square root of 6 is on this circle. So same steps. I plot a point at negative 1, 0 and at negative 1, 3. I draw the circle centered at negative 1, 0 that contains negative 1, 3. So if it is centered at negative 1, 0, which is here, and it contains the point negative 1, 1, 2, 3, which is here, then I know that my radius is 3. So my circle would kind of look like this. The sketch of the diagram isn't what's most important. What's most important is coming up with this equation of the circle. So we substitute in negative 1 for h, 0 for k, and 3 for r in order to come up with that equation. So our equation is x plus 1 squared plus y squared equals 9. So I have 1 plus 1 squared plus square root of 6 squared, and I'm checking to see if that equals 9. Well, 1 plus 1 is 2, 2 squared is 4, square root of 6 squared is 6, and the right-hand side I didn't do anything to. Well, 4 plus 6 does not equal 9. So the point, 1 comma square root of 6, is not on the circle because the x and y coordinates of the point do not satisfy the equation of the circle. How did we know that the radius of the circle in example 3a is 4? Because the distance from 0, 0 to negative 4, 0 is 4.